Hello friends, welcome to engineering tutorial. So we will continue with our discussion with the material science and engineering topic. In the previous video, we discussed the basic concepts related to this subject, and I just tried to give you the overall idea about what this subject is all about. So in this video, again we are going to discuss in a quick way about the various broad categories in which the engineering materials that are put into use in various engineering applications are classified into. Okay, so the engineering materials that are put into use in various applications, they can be divided into these broad categories. Okay, so whichever material you find around yourself, it belongs to one of these categories. Okay, so the various ways in which we can classify them. So first is metals, then ceramics, polymers, composites, semiconductors, biomaterials, non-linear materials, nanomaterials, and advanced materials. So we will discuss them in short. In the upcoming videos in future, we will discuss them, each one of them in detail, because each one of these engineering materials is a separate field in itself. So it is very vast in itself, the whole this whole subject of material science and engineering. So in this video we are just going to discuss them in a quick way, the basic definition, the related concepts, and in the upcoming videos we are going to discuss them in detail. So first is metals. So it is the class of materials which we all know, they have high electrical and thermal conductivity from the point of view of engineering properties. They also have the mechanical characteristics, they are very malleable and ductile. Malleable means the ability of materials to be beaten into thin sheets, and ductility is the ability of the materials to be drawn into thin wires, okay, the stretchability. Also they have high reflectivity of light, the optical characteristics. So here the electrical, thermal, mechanical, optical, and then it is the chemical properties. They have crystalline structure, okay, means they have a proper regular geometrical structure, and which is very symmetric. And the examples of the most abundantly available metals on earth, they are aluminum, iron, calcium, sodium, potassium, magnesium, etc. So this is the category of metals. We discussed the various basic properties associated with it. Now ceramics. So ceramics are basically compounds between metallic and non-metallic materials. Okay, so they are very lightweight but hard and brittle in nature. Okay, they have electrical and thermal insulation properties. So please note these properties, okay, electrical and thermal insulation, lightweight, hard and brittle. So depending on these properties, they have to put into use in suitable engineering applications. Okay, so here we covered the electrical, thermal, mechanical. Then they exist mostly as oxides, nitrides and carbides, okay, these ceramics. Then the third category is polymers. So polymers are basically organic compounds with a large molecular structure, and is mostly based on carbon, hydrogen and other non-metallic elements. And the suitable properties which they have, key properties, is that they have low density and low transparency to visible light, and they mostly behave as electrical insulators. Okay, and the most commonly used polymers that we use in our day-to-day life is plastics. Okay, so it is one of the most popular and common examples of polymers. Then is composites. Now the composites, they are materials with two or more components, okay, different constituents. Now each of these constituents, they have different physical, chemical, electrical and mechanical properties, and we just combine them together to give a material with superior characteristics, okay, as compared to the constituents, the components. So the composites, they have two main parts. First is the matrix and second is the reinforcement. So the matrix, it is the base material, okay, the foundation of composites, and the reinforcement material, they are combined with the matrix to give a product with superior characteristics, okay. So they are designed specifically to have a particular electrical, thermal, optical and chemical characteristics as per the requirement, as per the application, okay. So the electrical, thermal, optical and chemical characteristics are modified, are altered as per the requirement. So the examples of composites can be ceramic matrix composite, metal matrix composite, reinforced concrete. So these are the examples of composites. Then semiconductors, which we all know, it is the base, the foundation of electronics is on the semiconductor material. So semiconductors are those materials which have electrical properties that lie in between conductors and insulators. Now they are generally of two types, intrinsic and extrinsic semiconductors. Now we have discussed about semiconductors in the basic electronics section and the analog electronics section in detail. There I have discussed about the semiconductors, the intrinsic and extrinsic semiconductors. Then the electrical characteristics of semiconductors are altered by the process of doping, that is addition of suitable trivalent or pentavalent impurity to give us two categories of extrinsic type semiconductors, that is N-type or P-type semiconductors. So the N-type semiconductors, they have electrons as the majority charge carriers. P-type semiconductors have holes as the majority charge carriers. So each of these extrinsic semiconductors is used in different ways to give us various electronic devices such as p-n junction diode, and also it has it is of much use in power electronics also. And the most common and popular semiconductor materials that are used are silicon, germanium, okay. So they are mostly used. Then we have biomaterials. Now we have already discussed about biomedical instrumentation, okay. We have a separate playlist for that in a separate section. So biomaterials is the category which is used for biomedical applications, okay. So the properties of these materials are in such a way that they are suitable for biomedical applications. For example, replacement of diseased organs, design of medical instruments, various biomedical sensors for diagnosis and medical analysis, okay. So the biomaterials, the properties that are looked for designing biomaterials is that they should not cause any harm to the body, okay. So that when most of the sensors that are used for examining the biomedical signals, for example ECG or EMG or electroencephalogram, they come in contact with the body, so it should not cause any harm. Also they should have particular electrical, mechanical, optical and thermal characteristics which are suitable for biomedical applications, because the biomedical signals, they are of extremely low magnitude and are very much prone to noise and interference, distortion. So the materials should be selected in such a way that they do not cause any modification in the original signal, okay, the biomedical signal. So all the engineering materials that we have discussed, such as metals, ceramics, composites, polymers, they can be used as biomaterials, okay. So the properties of those materials should be selected in such a way, or should be modified in such a way, that they can be put into use for biomedical applications. So the various properties are considered for biomaterials, such as hardness, toughness, tensile strength, fatigue strength, elasticity, permeability to fluids, various body fluids, toxicity, as I said, should not cause any harm to the human body or any body parts. So various materials are considered, various properties and factors are considered for selection of biomaterials. Then we have is the non-linear materials. So the non-linear materials are those in which, if light is passed through it, the frequency and the intensity, they have a non-linear relationship at the output, okay. So this is the property of non-linear materials. So when a light of suitable intensity and frequency is passed through it, at the output, the intensity and frequency, they will have a non-linear relationship. So for example, let's say an optical radiation of a given frequency is passed through a non-linear material. The radiation at the output will have a different frequency, okay, which will be non-linear with respect to the input intensity. So this is the non-linear materials. For example of a non-linear material is barium strontium niobate. So this is particularly used to change the wavelength and frequency of the output of neodymium laser. So this is an example of non-linear material, which is put into use for change in the wavelength or frequency of a optical radiation. Then comes nanomaterials. So nanotechnology is a separate field in itself. Nanotechnology and MEMS, micro electromechanical systems, which have close relation with sensors, transducers and instrumentation. So nanomaterials and MEMS nanotechnology, they are also related to the material science engineering. So the basic definition of nanomaterial is that these materials, the grain size of these materials have been reduced to nanoscale, okay. So when there is a reduction in the size of these materials, obviously it will have an effect on its properties, the physical, chemical, electrical and optical properties. So depending on the properties, the characteristics, they are put into use for various applications. Now the nanomaterials are used in various fields, for example sensing, transduction, in biomedicine also it is used. Also it is used in aviation and defense research. So there are various ways in which the nanomaterials can be used. Then comes the final, which is the advanced materials. So the advanced materials are those which are produced from traditional conventional materials by modifying their characteristic properties such as electrical, mechanical, optical, thermal, to give us end product, end result, which has superior characteristics as compared to the constituents, the components. So they are used for high technology applications, the examples of which can be fiber optic communication, laser system, liquid crystal display, LCD. So these are the examples of advanced materials. So here we have discussed all the broad categories of engineering materials in short. So each of these categories will discuss separately, okay, because each of these category is a separate field in itself. Okay, so we'll discuss them separately in the upcoming videos. So this is the classification of engineering materials. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.